Okay, so we are finishing up the 3.6 material that we started yesterday. We already went through our first two examples, the perimeter of a rectangle and the two different versions of game Overwatch that Blizzard was selling and how much each of those versions cost. And now we are going through and working with our final example here. This is where we're going to get started today, and then we'll get going on the 4.1, 4.2 material and see how much we can get through for the lesson today. So continuing on with this material, we're going into number 3. So we're told Metallica is selling 2 new t-shirts on their new tour. One shirt includes the 34 cities and dates on their tour, and the other includes a mashup design of their 10 original studio albums. There was a combined total of 10,000 of these t-shirts sold, for a total of $332,500 at their first 3 shows. The Cities and Dates shirt is selling for $25, and the album mashup shirt is selling for $40. How many of each type of shirt were sold during the first 3 shows? Okay, so we have a lot that's going on here. And if you're someone who's looking at this and just saying, okay, I'm going to write an equation down right off the bat, I would be very careful about that. Because there's so much going on here, I would highly recommend that we start looking at this and seeing, okay, what information can I use? What is useful? What could I pull out from this? What could I not care about for this? Things like that. So most importantly, what are we being asked to solve for? So we're being asked how many of each type of shirt was sold. We don't care about, oh, the first 3 shows. We don't care about the fact that it was 3 shows, 5 shows, whatever. So we can just kind of cross out 3 through that. So how many of each type of shirt were sold? So we know we have 2 types of shirts. So we're going to have 2 answers to this thing, as we're told right here, 2 new shirts. Okay. One shirt includes the 34 cities and dates. Okay, so the number 34, does that have anything to do with solving for what type of shirts we have? No, it's just telling us information about the shirt itself, which we don't really care about, so we don't need that number in. We're told the other includes a mashup design of their 10 original studio albums. Okay, well, that's just telling us more about what the shirt looks like. So, we don't care about the number 10. We're told there is a combined total of 10,000 of these t-shirts sold. So combined total, that means however much of one and however much of the other, combined together, 10,000 were sold. I don't know how much of each. I know in combined, we get 10,000 of them that were sold, for a total of $332,500 at their first 3 shows. And again, we don't care about this part at the very end. We're told the Cities and Dates shirt is selling for $25, and the mashup shirt is selling for $40. And that's probably going to be useful because we know how much the total they made off of those are. So we're probably going to be using each of these numbers in here. We're probably going to be using the 10,000 showing up in there as well. Okay. So I'm going to jump us over to our whiteboard, but this is kind of this initial setup phase that we're going through with these, and this is one of the more advanced types of problems that we can be seeing showing up on this these types of problems. So I'm going to jump us over to our whiteboard, but this is the initial setup that we have. So I'll jump over to the whiteboard. Okay, if it's going to actually jump over. There we go. All right, so again, we're working with problem 3 here. So we're being asked, again, we'll go back to the overarching part. We're being asked about how many of each type of shirt was sold in the first 3 shows. So we have one shirt that's the cities and dates, and another shirt that is the mashup design. So we have 2 unknowns here, and I'm going to choose 2 variables to represent each of those unknowns. I'm going to use C for one unknown just because I want to. I'm going to use M for the other one. I'm going to label these for myself. What do each of these variables represent? Oops. So C is going to represent the number of cities t-shirts that were sold. It's the ones that have these cities and dates that were in there. I'll make a little clarifying. Cities and dates. And then M is going to represent the mashup shirts sold. So all we're using this for is to tell ourselves, okay, this variable represents one thing, this variable represents something else. That's it. So again, we're slowly going through and reading the problem and kind of building equations for ourselves as we're going through this. So we are told in the problem, again, this is the part of read, reread, and reread again. So we're told there was a combined total of 10,000 of these shirts sold. So we're going to stop there before we do anything else with this. So however many of these city shirts that were sold, the cities and dates ones, and however many of the mashup shirts were sold, the combined total is going to give me 10,000 total t-shirts. So however much I sold of the city plus however much I sold of the mashup, that total combined amount is going to be 10,000. Okay. And again, we're using the terminology in the problem. Use that English to algebra translation PDF that I gave you guys. It's invaluable with these types of story problems, so absolutely use it. I highly recommend it. I expect you guys to be using that. It's there for a reason. Okay, and the next one that we've been told in that same sentence, they were sold. There was a combined total of 10,000 of these t-shirts sold for a total of $332,500 at their first 3 shows. So I know the raw numbers of how many that were sold. That's our first equation that we just made there. And then we've also been told the total amount of money that they made based on the number of t-shirts sold. So we're going to be making some information with that. We're told the cities and dates t-shirt is selling for $25 and the album mashup shirt is selling for $40. So if I sold C, many cities and dates shirts, the total amount of money that was made off of that would be 25 times the number of t-shirts sold, because each of them cost $25. If I combine that with the amount of money I would make from the mashup shirts, which is going to be written as 40 times n, again, m represents the number of mashup shirts that were sold, and they were selling for $40 each. If I combine the amount of cities and dates plus the amount of money made off of the mashup, that total should equal that 332,500. So there we have our 2 really nice equations in there for ourselves. So our first equation that we have is representing the total amount of t-shirts that were sold, based on adding them together. And our second equation represents how much money was made off of the total amounts of t-shirts that were sold. I just like labeling these things for myself as equation 1 and equation 2. Okay. So now the question becomes, okay, so how am I going to figure out and solve this thing for each of these variables? Previously, we've been given some sort of information about what do I know about the relationship between the 2 variables that have been given to me. On this one, we aren't directly given that. So we have to do a little bit of workaround to make that happen. And we use substitution in a couple of the previous ones to make that work for ourselves to solve for these things. So we have to get a little creative with making that happen for ourselves. So what we're going to do, I'm going to take our first equation, so equation 1, and I'm going to rewrite this. So one variable is in terms of the other. So what I'm going to do, and I'm just arbitrarily choosing this variable to make it happen, you can choose either one, is say I want to get C all by itself on the left-hand side of this equation. Okay. Well, to do that, I'm going to subtract M from both sides. And when I do that, on the left-hand side, the M's cancel. And on the right-hand side, I'm getting negative m plus 10,000. And now I do want to clarify this for anyone that's maybe thinking, okay, well, what if I wrote it this way? You can write this out as c is equal to negative m plus 10,000, or, and it means the same thing as long as you keep the sign correct, 10,000 minus m. Doesn't matter which way you choose. I like having the variables in front as the leading term, I should say, personally, but that's just me. So now, at this point in time, so I'm going to use our first example that we have here. Now I have one variable, the c, in terms of another variable, m. So it's kind of similar if we think back to our examples from yesterday where we're told I have 10,000 more of one type of something we were working with, or I have 50 more of something over something else. And we had that relationship between the two variables that was given to us. So here, again, we have to do a little bit of extra prep work to get to that point, but now we are at that point. And from here, now I can substitute that in, just like we did yesterday, in for c in our other equation. So I'm writing that out for myself. So the other equation, give myself a bit of space here, I'm running out of that. And now I'm going to substitute in for c, this negative m plus 10,000. So I'm going to write that in here, change the color, make it stand out a little bit more. Okay. I'll make that a better 0 here. It's not a 6. Okay. So we started with two unknowns in this problem. We had two equations. So fantastic. That's the bare minimum we need to solve these things. However, one of them was not written as one variable in terms of another. What we started with. So we rewrote equation 1, that we did over here on the left-hand side. So I have one of these variables in terms of the other. And then I'm substituting that into the other equation for that corresponding variable. Now, I'm at the point where, great, now this entire equation that I have here, I only have one variable type that's in here. I just have m's. And now I can solve this thing for my value of m. And to do this, we're now applying the rules and everything that we learned from 3.5. So this 25 out front is going to distribute through to everything. I'm just differentiating the colors a little bit. So I have 25 times negative m. It's going to give me negative 25m. 25 times 10,000. And I'm going to plug that into a calculator because mental math. I'm getting 250,000. And then plus 40m is equal to that there. So again, all I'm doing is I'm just simplifying both sides of the equation right now before I add, subtract, multiply, and divide things to both sides. So I'm combining like terms on the left-hand side. I have an m term and an m term, or two m terms, I should say. Those combine together. To give us 15m. And now from here, again, I'm trying to isolate my variable terms to one side. I'm subtracting 250,000 from both sides. Again, apply your calculator. then divide both sides by 15. Cancels on the left-hand side. And we get our answer of 5,500. Okay. Now I'm going to pause the recording here really quick. I do need to use the restroom, but so I will be right back. Okay, so we have just gone through and solved this thing for our m value. I'm going to zoom us out here and go back up to our start of the problem. Now we were being asked to find how many of each type of shirt were sold. So the amount for cities and dates, and then the amount for the mashup t-shirt. So we just found our m value, fantastic. And now we need to find our cities and dates, our c value here. So what I'm going to do, I'm going to use my first equation here because it looks like it's going to be the easiest. And I'm going to plug in the value that we just found for m in for m in our equation here. And then we're going to solve that thing out. So working with that, oops, what's it doing here? There we go. So rewriting the first equation that we made. So again, the amount of the cities shirts versus the amount of mashup shirts combined together should give me 10,000. I already know the mashup shirt number is that 5,500 we just found. Equals 10,000. So now, if we want to get this thing out of parentheses, just like we have here. Now I want to get the variable c all by itself, so I'm subtracting 5,500 from both sides. Apply your calculator if you need to figure out what that value is going to be. I believe it's going to be 4,500. 4,500 either way. And we have our final answer. We know how many of the city shirts were sold and how many of the mashup shirts were sold. So we have our answers there. Okay. So again, there's a lot that's going on here. I'm zoom us out here a little bit. There's a lot that's going on here. And again, I think the hardest part with these is getting this setup portion down. It only looks like, okay, well, it's only 4 lines or so of writing that we need to do. It doesn't look too bad. Well, it might not look too bad, but if we do not have all of this prep work done ahead of time and we have the the equations set up correctly, then the rest of this falls apart and we're not going to get the right answer anywhere else throughout the rest of it. So make sure as you are going through these, again, I'll go back to our original problem that we had. As you're going through and reading up on these problems, what information is useful that we've been given? What information is useless that we've been given? So I'll tell you guys right now on this coming up, the test we have coming up here, I'm absolutely going to throw stuff at you guys where some of the information is useful, some of the information is useless, and you need to go through and differentiate what is and is not useful to solve out the rest of this problem. So do not rush the setup steps for this yourself. Again, I think I've said it how many times now, but I'm hoping it's ringing true, as it were. It's very important as we're going through these story problems. Okay. So with that, I'm looking at the time that we have here. We're going to get started at least a little bit on the 4.1, 4.2 material because we're obviously not going to be able to get through all of it today, but we're going to go through at least some of the starting portions of it, which is primarily working with some definitions. So I'm going to move us over to the 4.1 material, which is working with equivalent fractions. So again, a fair amount of this should be review because a lot of this was covered in the Math 62 material. So we're going to go through some quick overviews of fractions, quick thoughts with equivalent fractions, and then I will wrap up here in about 5-10 minutes or so. So working with our original core definition of a fraction, which is where all of this needs to be starting from. So our definition of a fraction is a number of the form a over b, where a and b are numbers, and that's called a fraction. A is representative of the numerator, and b represents the denominator. So whatever is on top in the fraction is the numerator, whatever is on bottom is the denominator. The other part, and this is a subtle part that goes along with fractions, but it is understood and it is implied that the numerator is being divided by the denominator, meaning that all a fraction is just a different way of writing out division. So a couple examples we have here. If I have a divided by b, that's the exact same thing as saying a over b. And we can go back and forth between these two however many times we want. We did a little bit with this when we were working with PEMDAS and order of operations with fractions, actually. So if we put some numbers to this, if I have 5 divided by 12, I can rewrite that as 5 over 12 as well. The last one that we have here is our idea of equivalent fractions. So our definition of this: two fractions are equivalent if they represent the same value. So again, equivalent, it's just different ways of writing the exact same thing, exact same meaning. So I think one of the most straightforward examples is using 1/2. So 1 over 2, it's the kind of fully reduced version of this fraction that we can have. Well, it's the exact same thing as saying I have 4 over 8, or 12 over 24, or 50 over 100, or 1,500 over 3,000. All of these, if you plug them into a calculator, if you reduce them down, they are all equivalent to just being 1/2. So that's all that equivalent fractions are. It's just the same thing written in different modes, I should say, or different forms. Okay. So creating these equivalent fractions, and again, we'll go through some examples of this, probably a bit more in-depth stuff next class, but at least get started with it. If you start with a fraction and then multiply or divide, no addition, subtractions, only multiplication or division to create equivalent fractions, then we're going to multiply or divide the numerator and the denominator by the exact same value. And that's going to result in creating an equivalent fraction. So very similar to when we were working with solving equations. Whatever I do to one side of the equation, I do to the other side of the equation. Well, fractions are very similar in that regard, except that's with the numerator and denominator. So if I want to create an equivalent fraction, maybe I'm scaling the numbers up. Maybe I'm making them larger. If I'm starting with a over b, then if I want to make those larger, I'm going to have to multiply the numerator and the denominator by the exact same value. Vice versa, if I was going to be reducing something down, reduce the fraction down if I can, starting with a over b, I would need to divide both the numerator and the denominator by the exact same value. So again, we have a little more formalized way of writing this out. When we make the values of a fraction smaller using division, we refer to this as reducing a fraction. So if I'm ever asking you guys on a test or anything, write your answers as fully reduced fractions, which you should always be doing. Pro tip for anyone that's wanting some advice for tests. If you have a fraction as your answer and you're like, how did I get this wrong? Or you're looking at something on the homework, how did I get this wrong? Did you fully reduce the fraction down? There are very, very, very few instances where we will not be reducing our final answer down, and they're very far and few between, so do not rely on, I just put an answer, it's probably fully reduced, I'll just move on. Always check that. Points are on the line if you're just going to skim through the answer, the test, anything like that. You don't want to have any of that left to chance. At least I wouldn't think we would want to do that. So we have some examples here, some ideas on how we could fully reduce a fraction down. So to do that, my recommendation is to determine the greatest common factor between the numerator and the denominator and then divide both of them by that number. And we'll go through an example or two of this next class because there is a kind of nice way we can do that. We're saying what's the largest number that goes into the numerator, what's the largest number that goes into the denominator, and divide both the numerator and the denominator by that value that you found, that greatest common factor. The book itself, if you're going through and looking at the lecture notes, the book says use the greatest common divisor between the two numbers. And all that is just, it's a different form of terminology. These two things are interchangeable. So if you're used to saying the greatest common factor, use that. The one that we've been using up till now, and there's nothing wrong with listing things out using this versus this. No difference there. I'm not going to be picky on that front, however you want to organize that for yourself. So how do we know if we have something in lowest terms? Well, the way we're going to be able to do that is if the lowest thing, the lowest term, we have a fraction in lowest terms if the greatest common divisor, or greatest common factor, for both the numerator and the denominator is going to be 1. So if I can only divide these things by 1, again, it's not really going to reduce anything down because anything divided by 1 is just going to be itself. So I can only divide the numerator and denominator by 1, I have this fraction in lowest terms possible. And again, as you're seeing down here, we're going to go through some examples of this, but that'll be for tomorrow. The alternate version that you can go about with this, and I'm happy with whichever one you want to do. You can fully factor the numerator and then cancel out numbers from both the numerator and the denominator from there. Should say fully factor the numerator and denominator, but same idea. So that would be the one where as we went through earlier in the quarter where we found the prime factorization. You could go through and use that if you'd like to. Again, multiple options on reducing these things down if you would like to use that. And then our cancellations rule says if we write these things as a product, fully factored, then we can cancel common factors from the numerator and the denominator spot, and we get an equivalent fraction. Essentially, it's the formalized rule of we can cancel things out and get answers. Okay. So I'm looking at the time. I am going to stop the recording here because I think this isn't too bad of a spot. And we'll come back and we'll take a look at a quick review of this tomorrow. We'll look at some examples and do the 4.2 material also. I'm going to end the recording here for today.